So we're going to begin, as we always do, with your questions, the ones that have risen to the top at least. So you've had a chance to vote on these, you've had a chance to look at them. And our number one question has to do with sort of mental models. A big part of science teaching is working with and testing mental models. Are there any ways to facilitate it besides inquiry strategies that take so much time? So what I'd like you to do is talk about this in your groups for a couple minutes. How can you get people to address making new mental models, the stuff that we all talked about last time, without taking up all of your class time? So take 3 or 4 minutes to go to it, and we'll share and see if we get some masterful ideas.
We had one ICS where we were drawing maps for imagine taking a globe, a globe, wrapping it in the plastic, putting a flashlight in the middle of that sphere, and drawing a continent, and then you would trace just a straight line like that, just with light projection.
But they don't know that they have misconceptions because they think that they're understanding what they're right. So they don't. If you say, "What are your misconceptions?" they won't know. Right. Because they just think that what they know is right. Yeah. Right.
So you mean like knowing up front what some of the things that might be in there?
When I was a geology student, I watched use our hands to kind of striking it. Striking it, explain in space, how it's behind space.
Yeah, I guess so.
I think that
There's always, our professors, maybe one of the things.
like little ones. But he actually had a syringe that he was pushing that helped him get to it helped him get to the air
But it didn't have a
gas
scale on it, so they didn't know if this was a giant sea creature or a tiny microscopic thing. You have no idea. Like, what is it?
Yeah.
Is it an animal? Where does it live? What does it eat? And they assume you know what it is, and they go on from there. When they're learning about the nervous system, it's the first example they get. And you don't know what it is. How would they know? Yeah.
so much easier.
Yeah, that's right. That's what you're about an expert in mind, right?
Gift or something like, oh, that's how that works. I was watching
Well, that's what people said class. So if it's but then it comes
Does it help to say
Don't assume experts in some knowledge. It just may not be correct.
so how do you move on?
You're not using the correct part.
That's right, man.
Whoosh. Did anybody solve any problems yet? So we should talk about the second part of it here. Oh yeah, we're not getting to number 2 yet. We probably won't get number 2. Strategies. Okay, so extend the class day, which some schools are doing. It's kind of neat, actually, even at the scene as I'm touring around elementary schools. There's actually quite a number of elementary schools now that are paying their elementary teachers to do tutoring for their kids after school. It sounds like
Like they have time for that?
Yeah, I know. I don't know exactly how it works in practice, but in principle, it's kind of a neat idea. If you had a robo teacher that was like unbelievably energetic.
Don't you guys all get up at 4 in the morning as it is?
Yeah.
What if the day before you address a new concept, you make the homework, tell me what you know about this subject? And
Okay.
then you can kind of know going in what the students are thinking about, and know what
Okay.
the misconceptions might be.
So in order to help correct those mental models, we need to know the mental models. And so that's an important thing. That doesn't take too much time. And a lot of the time we skip over our formative assessment. We skip over what do our students know already. So stop doing that. It doesn't take as much time as actual full inquiry would. What else?
Make a concept map that is kind of active and then they go back periodically and change and revise. Like, so they do a concept map with black pen and they put the date, and then 2 weeks later, they go back and look at it and revise it with red ink. So any additions they do are crossing outs, and then they do blue ink.
What's the big innovation there, other than probably a lot of us are not using, I don't use concept maps that much in my classes. So other than using concept maps, what's the big innovation there?
Well, to me, it's going back and revising your thinking.
Yeah.
It's like the backtracking and reevaluating.
It's institutionalizing the revision to thought process, something that we often skip over. And in fact, I realized I do this constantly with everything, including this class here. We've gone over a little bit of your concept maps, and I told you some things that were wrong, and I gave you feedback, but did I give you a chance to correct them for your grades? No. Building in, institutionalize those opportunities to correct mistakes is a beautiful thing, and making that an explicit part of the class. Of course we don't know the answers at the beginning of the class, but at the end maybe we will, and trying to give multiple opportunities to recover from those. So those are good. Other ideas?
Well, we didn't really finish.
You don't have time to finish it.
Okay. I mean, one of the things that we were talking about, we didn't finish evaluating whether or not useful or not, was replacing mental models with physical models run it whenever possible.
Okay. So
Instead of
I think I
relying
heard some of the using as much as possible tangible things, visible things, tactile things, human body things.
Molecular models. Like molecular models.
Okay, the things that you can build and construct and really illustrate.
Yeah.
So great, because you can draw analogies to what's going on in your hands. One minor problem: unintended samenesses. Those little sticks that keep things together. What are those? In real life, they don't exist. It's the intermolecular attractions and electrical attractions and things like that. So, so it's cool. Teaching the physical objects is always a great idea, as long as we try and make sure that we do as much as possible to minimize those unintended samenesses. Analogies are great, except when they aren't, except when they don't work perfectly. So the last 2-minute tool that I get to contribute to you is one from the university faculty level. If you want your students to be challenging their mental models, you need to challenge their mental models. And this is the 2-minute interruption to your class, because I don't need that, I need another tab. So I teach you about all sorts of great things about hydrogeology in my lecture. I've done my lecture. I'm going to take 2 minutes out of my lecture, and I'm going to show you this picture right here, and I'm going to ask you, where should I drill? At point A, point B, or point C? Where am I going to get the best? Let's see here. Oh, actually, this one. I'm injecting hazardous waste. Where should I inject my hazardous waste so that it doesn't contaminate my drinking water? And my drinking water is probably up in this top green area. And to solve this problem, Can you simply draw on your memorization of the definition of an ejection well? No. Can you just sort of? Hmm? You've been ejected. So you need to know what an ejection well is in order to solve. But that doesn't help you answer because you can inject stuff into well C, you can inject stuff into well B, and you can inject stuff into well A. You need to know what impermeable and permeable rocks are. So you need to know those definitions in there. But now none of those things help us answer the question necessarily. We need to know a third step, which is a conceptual question of what do we
Well,
need.
look at the diagram.
Well, okay.
Look at the table, I forget.
You have expert knowledge.
And
All right.
so interrupting your lecture with a conceptual question. If you want your students to be building robust mental models, what's the last step that you need to do? The last step in breaking misconceptions that we talked about last time that everybody agreed needed to happen? Apply it to new situations. That is what I heard most closely here, but I'm sure many of you said similar things to that. So applying it. You need to apply it. You can't have a new mental model and construct a new mental model unless you have the chance to test it, build it, revise it. And you need to give your students opportunities to do that with challenging conceptual questions. This is called concept tests. We'll talk about them maybe the next week. I forget exactly when. We'll be talking more about these sorts of things a little bit. But basically, ask higher order questions, get higher order model construction. And there's some neat quick tips to doing that that we'll go through. It's not as easy as it sounds, but some other quick comments about your concept maps. These are from today. So here is an example of something that was missing from a lot of your stuff. A lot of you had this great stuff about challenging misconceptions and this great stuff about expert novice. But then, how did you link the two? Some of you did that better than others. Here was just one neat connection that somebody made when we were talking about unintended samenesses and how to avoid those. You emphasize underlying principles, and this person said underlying principles help experts see things differently, and that's one of those characteristics of expert thinking that we're going to talk about after you do the quiz, which I might have given away an answer on. If doing that, that's great. So that's fun connections. Draw those connections across your maps, thinking about big connections. Another misconception to address here. A lot of you had things like this. Misconceptions form because of minimally different examples, or a type of misconception. For example, minimally different examples, or misconceptions that come from minimally different examples. Minimally different examples, do you remember why those were introduced, why we read about those?
You're supposed to use them to highlight the difference
Yes.
between things that might be misconstrued as sameness.
So this was this example of 1/3 plus 1/3, or 1/3 times 1/3, and the reading that we said suggested that you actually do put these two side by side. So you'd have the chance to see that there's something really important that you can't do. You can just go straight across in this one, but here, like, I didn't do the right one, did I? You can't just go straight across and add things up here. You've got to do something much more complicated and identify, even though these two examples are very similar, one's a plus and one's a multiply, this was a way to try and avoid misconceptions. Certainly, when you do this wrong, you might solidify a misconception, so that there is some truth. When you said that misconceptions can form because of minimally different examples, that is indeed true, but it wasn't the main reason we talked about them. We talked about them as being a good thing, and a lot of your concept maps didn't really accentuate that point. And lastly, a lot of you had, if I go back here, I don't know how many examples, but a lot of you had basically treated our remember we spent that time on the tricky vocabulary, and a lot of you had a heading called tricky vocabulary, and then you had stuff going off there, which was simply a reconstruction of what we did in class. So when I had us talk about intended sameness versus unintended sameness, You had that as a little branch off of tricky vocabulary. That's not the richest way to talk about those concepts. When those are verses, or even actually, let's take a different one. Let's take vernacular misconceptions versus, what was the other one that we paired it with last time? Sure.
Preconceived notions.
Here are these two things, and many of you had, here's a concept, and you have this link versus. But what you should really be doing is trying to think about, if you're doing verses, that means it's a side-by-side comparison, and they have some sort of thing in common. So what is the superordinate idea to those two things? Common misconceptions, but there's something in particular about these two types of common misconceptions that they share really in common. Well, one of them's language, actually one of them's not. Remember, preconceived notions was like when you see water soaking into the ground. It had something to do with observations. Something to do with everyday life. I have it written up here in a better way here. So the human brain identifies sameness, such as things familiar to what happens in everyday life, such as everyday words and everyday phenomena. When you have unintended samenesses involving everyday words, that's the vernacular misconceptions, and everyday phenomenon that you apply to things that don't quite work out right, that's a preconceived notion. Likewise, you're building on your pre-existing knowledge. Well, if your pre-existing knowledge is incorrect, that's a factual misconception. I mean, of course, things familiar to everyday life is one category of pre-existing knowledge. And incorrect mental models, so incorrect facts, incorrect mental models, these are both incorrectness, so maybe there's even another layer that we might want to add there. And so we're trying to really group these things together. If you're saying that these two things are side-by-side versus one another, well, how are they related? What's that superordinate concept that ties them together? And that's what you should be striving to do with them. And these, of course, get very big and ugly and very messy very quickly. But you can start seeing this sample. And this will be, when I post the slides tonight, this will be up there, so you don't have to copy it quite so rapidly here. You'll be able to see it. So questions about the sort of expectations of reorganizing the presentation of what's in class?
Well, I get confused because it seems we cover many different things, and then so I'm not sure if it's supposed to be, like the dominant thing is what we cover in class, or maybe the big idea. And so I was more focused on like the expert novices because that was connected to the reading. And I thought the misconception stuff was the week before. So I was starting to, because there's overlap from, like we just covered some stuff with misconceptions. Is that going to be on the next one? You know what I'm saying? I guess I'm a little confused about
So that is part of the challenge, is trying to figure out how the stuff we just covered relates to the new stuff. There are strong connections that we want you to be building on that. And so the concept map was next. Don't worry, our next end of day reflection is different format. So we're going to leave concept maps behind for a little bit and practice something different in this here. But so again, stare at that one a little bit later to try and rethink though about how you should be drawing the connections in the course. And now go ahead and take out a computer, one of mine or one of yours, and let's start our quiz.
Flexible. I think being flexible is part of medical.
Or adaptive, you know, like flexible, adaptive.
Yeah, sort of that.
They have particular details in the code, so they have variables they can plug them into an equation.
Okay. And then there's something else experts do. Well, they have a lot of background knowledge that the novices are learning, but just starting. But more importantly, they know how to solve problems. They know what approach to take. which comes from being able to organize the information and the big ideas, but it's more than just that, and being flexible, but it's more than just that. It's that they can solve problems based on prior experiences, which kind of goes with background knowledge. It's not exactly the same experience, yeah, I think goes along with knowledge.
Experts or approach or something.
Is that what you mean?
Yeah, so they can organize, so they can solve problems more effectively, or without having to go through the whole chugging through, is it this equation, is it that equation, which equation is it? It's more about the big concept as opposed to the equation, so that goes with the big ideas.
And so that goes to like the arrows like this.
It's kind of this way also.
Like that. And then
Then
it goes like
I would have one
here.
between big ideas and solving.
Here.
Chunking also helps them solve problems more effectively, right?
So does that.
Well, there you go. So it's nice, there's lots of things to point towards. And this does too.
Yeah.
Everything points towards solving problems more effectively. Novices, on the other hand, they have some, some information which they may or may not have turned into knowledge yet. Right? They sit in class, they...
Knowledge. They have some knowledge.
Yeah, some knowledge.
Just not.
Oh, experts are also not always good teachers. They could be good teachers, but it
Oh,
doesn't.
and that was another thing, was context and they can't tell you how they just do something.
Right.
They always
They know it,
explain
but they don't know how they know it. It's just so many years of experience has taught them this. Okay, so they have some knowledge. They kind of chug away at problems without necessarily thinking through the big picture.
Yeah, I posted this all.
Is that from
That's right from the reading. I forgot that was right in here.
Oh, yeah.
They can't draw on the same knowledge and experience that an expert
Does it
has.
capture everything?
They haven't yet learned how to organize the information.
Oh, so this is actually applying to a specific, this is how how expert knows apply to a specific problem. It doesn't actually, it doesn't,
I think so.
doesn't encompass everything.
that. Metacognition.
Remember the example of the
The thing
teachers
about the novices
who were
was-
looking at a classroom to see what happened in the classroom wasn't effective, and the expert teachers knew things like, these students have obviously done this kind of worksheet before, this is an effective way of them to learn something, they're working quietly, and the novice is like, I don't even know where to begin, I'm all over the place with this. So, it's knowing, experts are like knowing where to look, I think that's an important thing to be an expert. Actually, sometimes they overestimate their abilities or something. They may and overestimate.
Spend a great deal of time trying to come up
I
with
don't know how to
an answer.
articulate. That goes what you're trying to say, what you kind of understand, obviously, really try to see things.
Yeah.
Yeah.
Those are like all examples of metacognition or lack of.
There are 26 sheep and 10 years on a ship, how
That's the,
Right, there's no answer to that question, but the kids will answer, they answer 36.
It's almost like,
I think there must be an answer to every question.
examples of having less metacognition. So what were you saying over here was something? You're saying,
There was something.
what is this word? Something about.
It was the example in the classroom. Was it after that or was that it?
Yeah, it was something in the classroom, wasn't
Okay.
it? Oh, the teachers in the classroom, you said something about,
Oh, I had it and I lost it. It'll come back.
that we're able to, some teachers were better than others, but was it something
No,
about something?
we got not all
No, it
experts
was
are good
something
teachers,
about
but it was,
teachers
yeah.
being better teachers or.
Is that the experienced teachers could look at what's
Oh, yeah.
going on in the classroom and know just by looking whether the lesson was effective. The novice was like, knowing where to look, that's what it was. Experts know where to look. That's exactly what it was. Thank you. Jogging underground.
This is very true.
Yeah. And that was a big one that came up in all. And that's related to solving problems.
So these guys are more likely to chug away, so try a lot of different things, something like that. No, they don't. They look at just the things
I'm sure it's clear all the way through the end, but.
I got it.
That's it. Experts can apply what they know. Novices don't. to figure out which equation to use instead of thinking, what's the big concept?
In the end, they're like experts for
But
planning.
isn't that kind of what we have here?
You don't specifically say applying one thing.
I think they're both applying, they know, they just don't know as much. Well, yeah, they're applying some equation that they know how to calculate.
So, what was the saying about this versus expert, is there anything that's in common between
Yeah, that.
They do a better job, or at least better.
Sure.
Yeah, what do they have? Well, experts used to be novices.
Let's put that down. Expert used to be pointing that way.
I mean, that's the whole point.
Used to
Single
be.
antithesis of
And so that gets back to
That's really
metacognition
important.
too, that
Because it's not just, this person's a novice and always will be, this person's an expert and always will be, it's that this person is a novice but will someday be an expert. And remember, there's a whole section about what can experts
they
teach
always
novices.
know there's more to learn.
Right,
Right, that was on.
yeah, that's an important one.
They're gonna become virtuosos, that's what they're gonna do.
Start there.
They know what they don't know.
No, keep it. No, you're right.
Appreciate what they don't know or something. What was it?
And it was that,
Oh, this is the role of metacognition that we're talking about, the brain is a muscle, how do we get that on there? Right, they used to be novices, but because, this comes back to metacognition, so
well, part of it also is how do you turn a novice into an expert?
right, how do I get that on
There's
there?
gotta be a connection between them. I think maybe just a question, like many steps.
Do a what?
I don't know, like, I'll over it.
Do a what? Metacognition?
Novices don't analyze. I don't know how to do that on a concept.
Well, but it's got this metacognition, right? They have metacognition.
Really in depth.
Right, so that metacognition goes back to
The
this
thing is, they
somehow.
have it, the question is how do they?
But they had to have it back here to get to there.
Well, tying in with not always being good teachers, how do we get experts to teach novices how to be experts? Because a lot of it is just teaching the facts doesn't make them an expert, doesn't make a novice an expert. Obviously, there's something missing, right? It's the experience of doing what experts have done over many years that makes them an expert.
This, what I'm trying to get at now, how to put it on here, is that this metacognition allowed them to go from here to here. Right, because they were able to use their brain as a muscle and say, oh, I can keep doing this, and I can get this, and I can get better. And this continues all the way down through there. How do I get that on there? So this metacognition goes through from here to here to
This
here.
goes in both directions. Experts used to be novices, and novices want to be experts. We need one more going that way. Want to.
We hope they want to be.
Well, why would they take time in class?
Because they have to. But no, that's true. It's like there's this metacognition goes through from there to there, and then all the way down to there.
So then it's like, how
The experts want to be, so do we put like experts want to be virtuosos?
well, I mean, the novices might want to be also.
But they gotta go here first.
They're not ready yet, yeah.
They just see a billion details, you know, together, and they don't see the big pictures, you know, they just get all those kind of details that don't analyze, they don't see any pattern.
Both of those were examples.
It's almost like I wanna give make a metacognition line a different color.
Is problem solving still the right super?
Oh, yeah, I don't know. That was a placeholder, so we don't really put it on there. Do we wanna ask a question about how to get them to teach? How do we put that on there?
Yeah, it's, how do we teach novices to become experts or something like that, right?
How,
Because the,
like that? Question mark?
yeah.
You know, metacognitive monitor their own.
Okay.
Well, it could go either way. It could be, how does an expert teach a novice? Or
Oh,
how does a
okay.
novice learn to become an expert?
Okay, good. This is a double-ended area.
So
do we wanna
what's
change
a better
that?
superordinate concept besides problem solving? Problem solving is good, but I think there's some concepts that are missing. Like problem solving doesn't cover the novice and expert does, but it's not good.
Versus in there.
Versus in there.
Is it just assumed? Can we just assume? There's a versus in between there?
Yeah.
It's not the same, besides problem solving.
I read this article.
Approach to learning.
Well, it's a continuum, right?
Right.
It's the novice to expert continuum. It's that we're all in the process of learning.
Have your knowledge organized in terms of
Sort of problem solving continuum? Or is it just a continuum?
Well, yeah, a problem solving continuum might work.
That's if it's even on campus.
And we make problem solving better. We're not- Pull yourself compact. Look
Should we
at
put
us.
like any, should we
You're
put
already
any
doing the next
general-
step, which is to start cribbing off of people here. But it's useful to do when you have the time to, but to spot them. But so now,
There we go.
take a moment to start walking to the people next door and look at what they've got. And we're gonna sort of reconvene in a few moments here. So just take a quick look at some of their fun differences.
Like a square?
Yeah.
Yeah. Well, we're just being.
We're just sort of making yeah, just go where there's room.
There's an umbrella.
We all have a cool title.
Yeah. So I see some cool things. I see novices focus on familiar details. I've heard that from many of you. Is it also true that experts focus on familiar details? It is true, actually. It's just they have a lot more familiarity, a lot more depth to what their details are.
Well, then start with assimilated. Yeah. We're not automatically an expert. That's what we're gonna put novice and
Because all of this doesn't report further to guys.
Context. Mathematics.
Yeah.
There's familiarity that's chunks.
Okay,
We're a
go
conglomerate
ahead and
of
take your
geologists.
seats back down. Some of my favorite pictures are up here. Few things. See if you got the same things as I did. A lot of you did beautifully. One thing that is least strong in a lot of yours is perception. Experts see things differently. That was listed somewhere on some of the stuff that you have, but it really is. It's about you look at something and you notice different things. You notice the clouds or you notice the subduction zones because of what you're familiar with. You have background knowledge, which is organized. Quick recall allows organization. Problem-solving strategies. You've got a library of those. Those are not just knowledge or information. There's these whole. I can solve common problems that come up in this particular arena, and I think that's something that's also not as commonly represented in a lot of the concept maps here. And then, of course, the metacognition thing that we'll talk about in a little bit. So, just so before you go here for a break, I just wanted to share with you my fun little thing. Here I reviewed this textbook here, which has these beautiful pictures like this. And in the advertisements for this textbook, they advertise a stunning, pedagogically useful art program. It's stunning. Is it pedagogically useful? Is your thing to think about as you go to a break and come back here at, let's see, there's 15 minutes, 6:34. 6:34, which is a self-regulated process. So metacognition is something self-regulated. It's self-regulated learning. So self-regulated learning is kind of like self-control. Self-control means sort of being consciously aware of your behavior and controlling it. Yeah, the middle school teachers are laughing now.
I teach sixth graders,
Yes.
and none of them can do that.
Which is different than executive control, which is something that's actually a little bit less conscious in some senses. But self-control is this conscious thing, so self-regulation must be a conscious thing. And we're going to focus actually for a moment here on this first stage of things, or maybe the first stage. In order, it's a cycle, so you can look at it. This idea of you have to plan and set goals, then you're going to apply strategies and check to see if you're doing, and you're going to adapt. Remember, those experts are always adapting their strategies as they go. But let's take a look at this planning. And the first stage of solving a problem means to know where to start. Yes? And in fact, you actually need to really understand what the problem is asking, what type of problem it is. And experts actually do this better. They're able to quickly look at a problem and say, what sort of strategies are the most important for me to use? And one of the first things that actually novices are really bad at is just understanding what a question is and what strategy is going to be most effective to solving it. And this is where something that I'm going to show you in a moment, something that many of the teachers in the room are intimately familiar with and tired of hearing about perhaps, which is Bloom's taxonomy. If you want your students to be able to answer questions, they need to know what type of question, what sophistication is this question asking you. And I have just passed out to your table a little sheet of paper that has your very own copy of Bloom's taxonomy as I've written it. And for those of you that aren't familiar with this is a way to sort of categorize the cognitive complexity of a task. So at the very bottom, the simplest thing for you to do, if I ask you a question, I'd like you to memorize the answer and spit it back to me. To remember something. It doesn't require any level of understanding. It's merely memorizing definitions. This is the lowest level of learning. It can be accomplished pretty efficiently through rote learning. The next layer up, students have to be able to explain things, and these are some verbs related to tasks that are commonly done. This is how Bloom's taxonomy is often presented, in terms of the verbs of what you're actually asking people to do. There's understanding. Then you have to actually apply your knowledge. You can't just explain it. You actually have to apply it to solve a new problem. Analyzing, evaluating, creating. We're going to look at all of these things in a little bit more detail as an actual activity where you're going to try and put this together here. So I'm not going to go over them because you have it in front of you a little bit. But I have a short, sort of quick view of it. I like to label them factoid recall, explanation recall. It's a little bit oversimplified as to what the understanding level of Bloom's taxonomy is. Applying knowledge to simple problems, to solve simple problems, is sort of these next two. Planning a project kind of goes up in here. And at the evaluating stage of things, you can look at argue, defend, judge. Some of those things don't quite fit into that, my simple version of it. And then actually creating something from scratch and executing that creation is the highest level in Bloom's taxonomy. Yeah,
So Bloom is using understanding differently from what we just said, which is problem solving first requires understanding the problem.
Yes, yes it is. Yes. We have a
vernacular
vernacular misconception problem here about the word understanding. Understanding here, which is simply it's not nearly related to the whole beautiful knowledge and organized knowledge structure below it. This is merely being able to describe, to explain. Why did the colonists not like the people in England? What did they do to them, and why was it a problem in their lives? You have to be able to sort of answer a short essay question. Often, why is a nice way to begin one of those things. judging is way up here. Judging whether or not the colonists should have done that. Was that the best approach for them to do? Higher level question to ask. And so an expert will instantly look at a question and sort of say, I think I understand what level this one is, so I know what strategy to use to try and solve it. Because remember, if your novice is coming in there and you ask them to address, was the colonists' reaction to the tax of 1775, the teaching, was that an appropriate reaction? And they're thinking, gosh, what factoid can I recall to answer that question? They're not going to be doing very well. They're not performing very well because they're completely missing the level. And this is sort of the first stage of solving a problem, is figuring out what level it is at. And so for you to do this, I'd like you to go onto Moodle, and I have a little Bloom's taxonomy item there. And you can do this with your teams. It's not a great thing. It's a bunch of questions are shown to you, and your job is to sort them into different levels of Bloom's taxonomy. And like I said, do it as teams, do it as individuals, get it all open however you wish.
Number one? Just remember.
And there will be debate among you about some of these. There are multiple things.
Maybe we should look at a few of these like survey all the examples.
Yeah, but it's asking how long will it take, so you have to measure that, you have to calculate, do some kind of calculations, right?
Right. There is the word solve exactly appears in one of the verbs on there. You can find that.
More than just a matter that a volcano has general resources very large. Okay, fair enough. Fine, yes. I agree. Okay, so the cost of that, I think that would be my analyzing. It's more than just spitting back an answer.
It's hard. Yeah, it's harder to assess the level of taxonomy, even if you are familiar with it. You are.
Well, it depends on whether if you're told if tsunami is caused by, then it's remembering that's important. But if there's two questions, like how detailed the answer is.
I'm sorry, what factors? I read something. I thought it was how but how you would work to mitigate those hazards. I think it's creating. How would you mitigate? How would you work to mitigate those hazards? You'd have to come up with.
Whoosh! Quick interruption. Feel free to disagree as a team and put multiple different answers in there so that you can, if you're sort of vacillating between them, this is just a quick survey of If you think you can agree on all of them, one thing, that's fine. Hedging your bets.
Locations are not most likely to use on-base volcanoes, you do some on the fire, but I think it's quite hard to know. Remember your understanding. You probably have seen, well, if you've seen the
that argument, that argument I agree with. Your argument, that argument I think I do agree with.
There is classified,
Analyze it, compare and contrast, criticize the sheet.
Because you're evaluating what
Map those.
Yeah, if it was faculty wide,
Choose
it would just be
interpret.
Nine is definitely design your strategy.
Map no false responses, master spec activity.
That's definitely. There's something we may not hear.
No, a seismogram.
Well, the question is, do you have to think about it, or was it like the presentation?
Yes, the seismogram demonstrates how this works, right? You don't have to show me a picture of the seismogram.
Okay.
Yeah,
We have different answers to this.
yeah, it's.
That was a
On a seismogram, shown below the so don't give them a 5-down figure having to locate something on this. Maybe this is debatable.
Which I did, was overnight other New Mexico based on that definition. So to me, it's I didn't even know we had any in New Mexico, and I went, it's like, that's right, I thought it was standing in Hawaii.
Well, no, I can't get past Beltzman. What is it? Phillips Month. He's still bugging like 6 months. Yeah.
Unless it's out, they're on repair, identify the first one. Oh, no, it's how you would work to mitigate.
Yeah.
Look at the next
Okay. So 5, I have analyzing. Which area is the most compared? Yeah, think about it. You can't. It's a higher order.
I think he specifically chose this example because of its brightness.
Well, but if you've seen it before, then just remember. If you haven't seen it before, think about it then.
Yeah, it is.
Classify, identify, locate, recognize, and
But if it's recalling a point where. Okay, so actually you're gonna put this
unless it's compared, contrast, criticize, differentiate, discriminate, distinguish.
But you have to explain to them.
Scientist comes in.
So they're going all the way.
Yes.
Okay, so you can say
It's not really doing this, it's really writing, they're defending it, creating.
Yeah.
It's gotta be.
Both design and
You aren't generating the way you're doing things.
Okay, you know,
Which method is best?
it's not showing.
It's showing you my one response.
Yeah. Oh, yeah. 1 of 1?
Yeah, which one do you think? You're not generating.
Oh, there, he's got it.
Okay, try and race to the end here.
Race to the finish. No, race to the bottom.
No, that just means 100% of the responses you gave are here. So you can see the plots I have here. It's your response, not
You and I both.
Also, what do we need? We're supposed to unite. We said we did computer.
Yeah, we do it together.
Okay, I'm gonna submit now.
Go ahead and get there.
Thank you for completing this plan.
11.
11 of you. Anybody else want to put their last minute votes in here?
Well, that was fun.
All right. So, briefly here, you're going to notice that almost, let me just quickly scroll down here. None of you agree 100% on any one of these.
Let's go with that.
So, thank goodness is perhaps, they're all designed to be, but there's a reason why as we go through them. Let's talk about here. So, 9 of you said that what causes a tsunami is a understanding level, but 3 of you said, actually no, it's just remembering. So how is this, could this be a remembering question?
This is what causes tsunami.
So if you've been given a correct definition and you are expected to simply return that back, it's merely remembering.
It could mean they understand.
There's a little bit, usually these types of things can be a little bit more involved. If you gave somebody an essay question to explain what causes a tsunami, you would expect them to have a little bit more information that connected pieces together. So that's why more of you said understanding. Okay. Here we go, this one here, evaluating, analyzing, applying. Most said applying for this calculation problem. Some went as high as evaluating. Let's see, who voted for evaluating for this? Let me see what verb you used for this. In this particular case, solve is one of the verbs on there. You're probably going to look for that one. How could you turn this question into a remembering question? I'd love to get an answer. But there we go. What equation do you need to use? Actually, or what is the equation for calculating how fast waves travel? Or something like that. That could be a
Which one is,
Still,
which
you have
one of
to
these
solve
waves
it.
is the S wave?
That's an interesting one. That's
That
which
would
one of
be
these is
remembering. If you show them a diagram and say which one is the S wave, then they go, boom, that one is.
well, it
The one
depends.
that comes second, that's what they're remembering.
If they're showing them the diagram, if they haven't seen the diagram before, it's not just simple remembering. They're actually doing a little bit more than that. So,
Yeah.
all right, okay.
I don't know how that could be a remembering question, because you still have to solve it, even if you remember the equation.
Which?
The two.
Two is not a remembering question. But how could you change this question to make
Change
it a
the
remembering
question.
question? You just ask
Yeah.
for a different. You ask for something different.
Yeah, we did
You have to
that.
ask for something different. Okay. This one here is a lot of fun. The volcano with gentle slopes. What kind is it, and what is it made from? 6 of you went down to remembering. 4 of you at analyzing. Those of you that were analyzing, what were you doing? What verbs were you doing?
Interpret.
Compare.
Comparing and contrasting.
Comparing, contrasting.
Differentiating.
Versus the remembering. If you answered comparing and contrasting, how come some people saw this as a remembering question? You memorize gentle slope volcanoes are made from basalt. They're called shield cones. Sort of part of this. So it depends on this question could be. It depends on what the context is of the instruction, as it was phrased over here. What was taught? How is it being assessed? And if you taught a correct answer to this particular factoid, or they read this particular factoid, then it's there. Whereas if you're looking at, actually, this becomes an analyzing question much more if you are looking at a volcano and asked, what is this volcano made out of, or what type is it? It's a picture, showing a picture instead of asking this question with the word. Because then they have to do a little bit more. They have to know this answer as a remembering question plus some more. Okay.
I think I'm a little confused about the verbs classify and choose.
Okay.
Because what left out to me at that question was you have to classify the volcano.
Okay.
That's the first step, but I don't know, that may be a flawed reasoning.
It could be, you're right, absolutely right. This could be a classified. A volcano with gentle slopes is which category does it go in?
Yeah.
But it depends on how many criteria you've got. If it's simply a one-to-one, like all gentle slope volcanoes are shield cones made out of basalt, that's not really a great classification. That's not a really rich classification question. It's so simple a classification that it's almost a memorization.
Okay.
But if there were a couple more criteria you'd have to use to put together,
Analyze them.
you'd get up a little bit higher when you remember them. But it's,
So much of what, like with ESL, a lot of times when they're scaffolding stuff, the kids are told to focus on key terms and say, well, that key term means this thing, and that's how, because they can't read big long passages, they get confused, so they're they're told to pick out the key terms that look important and then connect it to something. And that, to me, seems to keep going, pushing it down towards the remembering part and less about.
A constant struggle.
Yeah, so that's why ESL is like really challenging for some of the kids who are just struggling with the wording to be able to do some of the higher, they're capable of doing it, but how do we do that? How do we get them to understand the question well enough to do the evaluating? If they're just, all they're doing is focusing on, well, gentle slope means shield. Do you know what I mean?
No, it's a wonderful challenge, and we could spend days talking about what the answer is. But instead, let's try and go on to our next one here. So a really neat comment though, that yes, the types of things you do in your classroom, types of questions you ask, push you above or below on this diagram, and therefore your expectations for your students have to go above or below. Okay, this one here, almost all of us agreeing. Evaluating, and just one applying right below that. Oh wait, actually two below that anyways. But a lot of agreement on that one. Well, location on the map. This is not a memorization question unless they've seen this exact map before. They have to think about a couple different things. Some of you centered on, even though there's not agreement, you centered on nearby levels. And like I said, we're splitting hairs at some point here as we try and nail it to one specific level of things. So don't worry about that part. Just getting this general idea. If it's a remembering question, it's a different strategy than a creating question. Here's on the seismogram shown below, labeled the S-wave. Many of you said that was a remembering question. It depends on what the S-waves look like and what the seismograms look like. That can be quite a challenging task, requiring a lot of expertise. If you're looking at a very noisy seismogram, that trying to figure out where is the S-wave, where should it be, and those sorts of things. So it can be a very high-level thing. Or if you're looking at something that's basically from your textbook and it's the same one every time, or something very similar and it's very obvious, it's pretty close to remembering. I probably wouldn't put it quite that low, because diagram labeling never is quite so low unless it's, well, anyways, this is a little bit higher than just a simple memorization thing. You have to know S-waves comes second. That's a memorizing feature. That's a remembering. And where is second on this? And that where is second is not something you can quite memorize so directly. So I would disagree with many of you that put that as remembering, unless of course it's exactly the same figure, which many of us see, or whatever we're going to do.
I was thinking of a geophysics sort of problem where you have a particular wave hits a boundary and it breaks up into a P and an S wave.
Okay.
And they have different velocities. So in that case, we just need to know if it's top or bottom.
Ah, okay.
So
Cool. What three factors are most important to determining how strong an earthquake will strike your city? Many of you said remembering, because you are given in your textbook a bullet point of three factors. It can become a higher order question if it's left, as you were saying, how can you modify this to become a higher order question? You could ask even just what factors affect.
Well, I interpreted that to mean you're picking from more than three.
Could be.
So,
and if you're picking from more than three, it becomes a higher order question. And what level does it come then, Linda?
I put, I just forgot. I think I put analyzing, but it could be.
Because if you're trying to look at a bunch of different factors which might affect your earthquake, absolutely, that is analyzing. Yes.
It might also be the city. I mean, San Francisco's issues are bridges. A lot of it's about bridges. And how would you might pick something because there's a little bit, in LA there's a lot of hills and, you know, it just depends on the city. Kansas is flat. Kansas City would not have the same, I don't know.
Well, so you're trying to figure out how strong an earthquake will shake your city. You're interpreting strong in a certain way, and so that affects things as well. What do you mean by strong?
Yeah.
And there's a amplitude of the shaking is one definition, or strong could be how big an impact it has on your city.
Then
Which is
about
sort of
the
a
building.
bigger issue.
That's too much.
Even if there are 3 bullet points, you could give a specific area, region, and say what is the most, like, you open-endedly decide which is the most important, like Mexico State's.
Okay, yeah, so in this particular spot, it has one criteria that really has a big impact on it. Can you identify it? Is that, what level is that though? Mexico City is,
Well, or even generically, what would be the most, but they're not even saying, telling them that there is one, just like
Yeah.
totally, like freely implement what you think is going to be the most safety, the most important.
yeah. So simply a little bit of twist to your question can boost it up on Bloom's taxonomy to be more interesting, more sophisticated question. Right, we're going to quickly go through here. Most of you agreed on that one. Many of you agreed on that one. And many of you agreed on that one, so we're not even going to go over them because you all have kind of similar levels, except for this last one here. Outline a lesson plan that teaches students about earthquake waves. Understanding is a really low level here. And this is outlining a lesson plan, which is kind of an open-ended thing. You can do anything you want with your students. It requires a fair amount of creativity to accomplish that. So our final question then is this activity that we just did. Where's it fall? We're trying to understand Bloom's taxonomy.
Evaluating. Analyzing.
I think so. We judge.
Comparing and contrasting.
That's right.
To support our reasons.
We definitely evaluated
Yeah, so actually, yeah, Claire brings up a really good point, is that the actual questions actually are asking you to simply discriminate or distinguish between things, but then in the group activity here, what did you have to do, Claire?
Defend our points of view and
Had to really defend that with evidence and support, and so the actual, what you were doing on the ground actually is a pretty high level at evaluating, as you were trying to justify your answer to your teammates.
Okay, but even if you're not doing it as a team, don't you have to, you still have to, what's the word you just used? Support it to yourself, I mean internally, right?
Yeah, to some degree you fight over that with yourself a little bit, but some people fight less with themselves than others.
We're experts now, you know?
So, fun. You're getting the point that this is important for us to do. So let me show you why this works, and I've heard some of you talk about this. My fun example here. So experts automatically recognize where on Bloom's taxonomy a question falls, and they choose the appropriate problem-solving tool from their vast internal library of problem solving.
You mean teaching experts?
Teaching experts will choose the right lesson to teach what they want to teach. And so here is, has the student grasped the nature of the question? This appeared in your video here. Okay, I'm not really sure if, do I need to, we can graph it, right? A line plot, I guess, histograms, bar charts, maybe a box plot. Oh, no, a histogram, anyways, are they clear on what level of complexity this problem is and where things are? No.
Please.
So, looking at this here, what also is fun too when you read this here is it just keeps going the same way the whole time. Yes, no. It's just sort of, what's the strategy they're using is remember every topic that I've ever learned and just say it, every word. That's the strategy. It's not changing as they go through and say, that's not going to work or whatever. So the next level after you recognize the problem is to check in with yourself. Am I solving the problem successfully? And monitor your progress so that you can eventually do this. Let me give you the fun example here. It's sort of a geologic example, it's not really. So here's this mountain. And your job is to move this mountain, to remove it. And we're going to use a rock hammer. And an office says, 16 hours. An office says, I'm still not done. I better hammer harder. And what does the expert say? Yeah, I think you're going to need a jackhammer. And this happens over and over again with my students, at least. I assume yours as well. Is that we've taught them actually relatively successfully sometimes that harder work pays off. But we forgot to mention the other aspect of that. Hard work is one. But work smarter, not harder, that phrase, you've probably heard that. So they'll sit there and they'll try and move that mountain using the same strategy over and over and over again. And so when I have to say to my students, how long did you study for the test? They'll say, I spent 12 hours studying for the test. And I look at what strategy they used for my conceptual level tests that I'd have to apply knowledge in this great way. And they'll say, well, I rewrote the entire textbook chapter by hand. And it took hours, and they showed it to me, and it's got highlighting everywhere, and it's like, but how is that going to help you apply the stuff? There were practice problems you could have done, and things like that. And so that's an example of a novice continuing to hit harder when they really should be doing something different, and recognize that. And here it is. I spent twice as time studying for this test than last time, and I still didn't do well. If you didn't do well last time, studying twice as long might help, but maybe different strategies. So we're going to do a fun little activity where you're going to see this in action. It's based upon thinking aloud. And how many of you are experts in faults? Faults. Some of you.
Yeah, especially not an ace.
Sure. In fact, on your little notes there, and some sheet of paper, just jot down, here is a wrapper. The beginning of this activity. How confident are you that you know the definition of a fault? And you can actually, let's even give you some numbers for this. Just, let's go 0, 1, 2, and 3. So write down some quick numbers. How confident do you know the definition of a fault? 0 through 3. Give yourself 3 points if you're very confident. None if you have no clue. Know what features to look for when identifying a fault. Give yourself 0, 1, 2, or 3. So I'm gonna give myself 3. I'm gonna give myself 3. And can identify a fault in the field. This happens to be my area of expertise. For PhD, I should get 3. I get 9 points total. How about each of you thinking about things? What you're going to do now is I'd like the person who had the highest number on your team. So you're going to have to share your number with your team.
I got 2 and 3.
Yeah, that person is going to talk. Hey, what's your highest number? Okay.
You got 5?
Okay, whoosh. Alright, the person with the highest confidence is going to take that little sheet there, and they're going to, why don't you all take that little sheet out, the folder I gave you.
The first one?
The first page, take a look at that. Some of you have different first pages. Actually, all of you have different first pages. And then, okay, put the first page aside, and take out the second page. What you're going to do is you're going to talk through how you decide if there is a fault in the picture. So you're going to, and everybody else on the team is going to listen to you talking, and they're going to fill out the fault training form in Moodle. And you're going to try and assess in that fault training program. You don't actually have to tell me whether or not there's a fault. You have to tell me how hard is it to find a fault in that particular picture. Was that one that was easy or hard? No, they're not. I don't think. I think they're all just bad quality pictures. And there's a bunch of them in there. And go quickly. In fact, actually, we're probably only going to have time to do about 5 of them. Yeah, you're mostly more than one. So you have to get out the. And you might want to start by.
The first one, but since I don't have a sense of scale, I can't.
Right. It's a great factor.
You're supposed to talk about it. And they're not here. You're talking to yourself like they all say.
This one is not a fault because that's not a process. guess tell me.
Maybe the picture taking some but.
Yeah.
Are we supposed to fill them out individually or is it team? Pardon? Are we filling them out individually or is it team?
No, Rachel is filling it out. You aren't touching it. You're talking.
You're telling me where it's
I'm telling you it's easier.
Well, you're talking about how you determine whether they're default insurance. You get to decide actually. Based on
Do you want us to do this individually or?
each of the individuals here is responding to that. You don't need to respond there. Sure. You can respond here, and only one of them at a time. They can take turns describing.
Yeah, and that was
But your job is to decide, is it easy or hard to find fault in this one? There's only one person talking. No There is two sides. Or second number two out. And in the process of this, you're trying to figure out describe and recognize the fault in the theaters. Because in the next stage, everything's taking quiz on so you have to teach her by only talking out loud. You can't teach her, you're just thinking out loud. But,
Are we done with this?
This is the side view.
I thought you said